Hello and welcome back to this crash course on exponentials and logarithms. This last one here, we're going to combine a few things that we've been looking at, and we'll just try to solve this for x. So again, we've got 5x is equal to 4 times 3 to the x. So when we're looking at this, what we would do before to try to solve for x is we just take some logarithms. And if we try to take some logarithms, we'll notice that this side, if we take a log, sure, we can just bring the x down and everything's fine. Over here we have a 4 times 3 to the x. So we'll have to deal with this product in here. Bringing the x down isn't going to work as smoothly as it did before, but there's only one extra step in here. So again, it doesn't matter what type of logarithm we use here. So I'm just going to take the natural log of both sides, natural log of 4 times 3x. And what I'll do is in this next step, we can start to simplify. So the natural log of 5 to the x, again, using the power rule, we can bring this down. So it's going to be x times the natural log of 5. On this side, we have the natural log of two things being multiplied together. And this should be ringing some bells. When we are multiplying inside the log, that's as if we are adding these logarithms together. And furthermore, we've got 3 to the x up here, so I can pull that down in front using our power rule. So even though there's this multiplication here, we've got a number without an exponent on there, it all just falls apart when we take the logarithm. So now we need to solve for x, and we'll move this to the other side. So we've got x natural log of 5 minus x natural log of 3 is equal to the natural log of 4. And pulling out the x and then dividing, we get x is going to be equal to the natural log of 4 divided by the natural log of 5 minus the natural log of 3. We could pull this into one logarithm if we want, but if we're typing this into a calculator at the end, it's not a big deal. So the last thing that I want to talk about is how do we calculate the log of a number? Sorry, it should be more specific. Log base b of a number when calculators only have log and ln. So when a calculator only has log, if you see a log without a base, it means log base 10. So the two most common logarithms that we'll see are log base 10 and log base e, which is the natural log. So calculators will often have these buttons. They won't often have log base b. Well, it turns out that there's a nice trick that we can use, and the log base b of x is going to be equal to the natural log of x divided by the natural log of b, or the log of x divided by log of b. So it doesn't matter what this base is. We can always write things in terms of natural logs or log base 10. So if we think back to one of our early questions, which was 3 to the x is equal to 30, and what I did was I took the natural log, and I took log base 3 of both sides, and we found x is log base 3 of 30. When I calculated this, I didn't type in log base 3 of 30 into a calculator. Most calculators don't have that capability. What I typed was the natural log of 30 divided by the natural log of 3. So this is a very nice trick for actually computing logarithms. And this has just been a really quick sort of overview of lots of properties of exponentials, logarithms. We'll do more throughout the semester. Please, if you have questions, ask me, but we will review this as it comes up again.